Hi, my name is Franco Venturi and you're about to watch a short video whose title is Live Migration of SV guests using QEMU. The reason why I thought it would be interesting to show demonstration of live migration of SV guests is first of all because OSV is a library OS with very small footprint. There's not much other than the application that runs running on it. It would be interesting to see that memory should be very efficient and it should be fast to migrate. And second is in comparison to other live address technique like LXC Dockers and container approaches, which I don't think offer the advantage of live migration. With USB and QEMU, we should be able to show that. For the QEMU KVM migration, I follow the instruction in the link highlighted here. I also added a few networking components plumbing in order to be able to communicate from my client, which is a standard API client, to the instance running. And finally, I added to the standard image a little Lua script called loop, which basically is just a loop that every second prints out a timestamp, a counter, and through taking this loop, we will see that the counter has increased, so the migration is transparent to the application. The status is preserved during the migration. The script is here, and I can of course post it online. And now we're gonna look at a couple of examples. The first example is one I called intra host. So the intra host example is better explained here in these two charts. The chart on the left shows what happens before the migration. So we have my Ubuntu workstation here, two OSV instances, one is running, the second one in CLI, an OSV bridge that is just used from the client to connect directly to the two instances. And after we're going to issue the migrate command, we're going to have actually the CLI application running on the second instance, while the first one will be idle and will show that it can be stopped at any time. So here we go. Let me just start the two instances. This is the instance is going to be active at the beginning, and this is going to be in standby mode. And notice the argument incoming TCP0444 for the listening configuration. Now we're going to start the client, and the loop every second is going to show me a timestamp. Okay, so now we are ready to initiate the live migration, and you'll see pretty quickly. Here we go. Issue the migrate command. And you can see the migration is completed. The one thing I want to now show you, which I don't know why it happens, the timestamp now went from February 20 to February 13 and 1 p.m. That's something I don't understand why, but the counter, you see, continuously went from 20 to 24 without interruption, just to show you that this instance is no longer active. I'm going to actually exit from here. And as you can see, the process continues without an interruption. So this is the first case, and the second case I want to show you is the so-called interhost. So now we're gonna do something slightly more complicated. I have okay, I have the following configuration now. And in this case, now we're gonna have still my workstation. I have two Fedora 21 servers called host A, host B running inside my workstation, an OSV bridge, which is the same that we used before, plus two little OSV bridges here inside the Fedora servers, which are not shown. And now we're gonna have OSV running on the first host, and we're gonna migrate from the first Fedora server host to the second Fedora server host, to show that it can resist even the failover, the live migration happens even across servers. So let me just SSH into the two servers. Let me quickly start on the two instances. this is the one on host A, the one that is going to run indirectly, so I'm going to connect to that directly. The one host B is the one that is going to actually run in listening mode. Okay, notice the flag. Of course, you have to add the two image user images and a phase share between the two. That's important, at least according to the instruction they gave us. And I'm gonna restart the loop. So now we're gonna do the migration across here. So we're gonna just issue the migrate command here. And you can see the time switch again from 7 AM to 01 the 13th. But now we know this host is no longer used, so we can actually exit from here. And the communication is running on the other one. We can actually show that it can be fed back. So let me start on host A the same way. And I'm gonna fade back from host C back to host A. There we go. And now as you can see, the counter keeps running, and you'll see that now the host is running back on host A, and we can actually stop host B, and we should be all good. I mean, stopping host B running host B. There you go. So this concludes my demonstration. As you can see, we can fade over. The only issue that I like to investigate or research is why the time here in the timestamp changes abruptly when the migration happens. But the fact that the counter didn't change is definitely a sign that the status is preserved. Thank you for watching.